It sends out one of each of these. It's going to say, I'm going to send out Cisco LMI, ANSI LMI, Q933A LMI, and whatever the frame relay switch answers from and says, hey, that's what I speak, that's what I'm going to use. So it's going to dynamically assign that LMI type to your interface. And on recent versions of iOS, LMI AutoSense is the default. So you generally, when you're setting up a frame relay circuit, you don't have to worry about LMI because it's going to handle it for you. There are two types of LMI messages. There's the status inquiry message and the status message. So the inquiry message lets the device, the user device, the router, say, hey, what's the status of the network? What PVCs are available? Are you still there, Mr. Frame Relay Switch? I'm trying to talk to you. And then the status message is a response to the status inquiry message. So that's going to be sent from your frame relay switch. On Cisco routers, the LMI is going to be sent out, and when I say LMI, I'm talking about the status inquiry message sent to the frame relay switch every 10 seconds. And here's a packet capture of an LMI status message. So this is coming from the frame relay switch going back to the router, and you can see here it's using DELC0, so that means it's either going to be Annex A or Annex D. The protocol is going to come up as Q.933 in Wireshark, but if you need to know the difference, you will see down here that the report type will show you that we are running ANSI here. And if you could see this whole packet capture, you would see that every 10 seconds or so, a little bit of differentiation, a status inquiry message is being sent from the router to the frame relay switch, and then it's responding to that. So that's that keep alive functionality that it has. Alright, getting to the end here, we're going to take a look at some additional frame relay features. Not going to go into these features in a whole lot of detail here, but we're going to go into much more excruciating detail in future lessons. But these are the very important and useful features of frame relay, and that's traffic congestion notifications as well as oversubscription / traffic shaping. So as we saw back there with that frame relay frame, and specifically the header bit of that, there are different fields in there, and a couple of these are going to be the FECN and BECN. It's forward explicit congestion notification and then backwards explicit congestion notification. Again, these are almost universally referred to as FECN and BECN, and those are going to report on congestion in either direction on the frame relay cloud. So that's going to help your router know if there's congestion there, and there's a lot that goes into congestion notification, and it ties into the other bit here, the frame relay traffic shaping. The key bit there is there's going to be a discard eligible bit that could be set. Prioritize certain packets for discarding. So to basically mark them for death. And it sounds like that wouldn't really be too beneficial, but it is, because it's going to let you say that, if you must drop these packets in the cloud, please start with these packets because these guys are not as important as the rest of my packets. Now, the cloud is managed by the carrier. They might say, sure, we'll follow that, or they might just say, go get bent, we're just going to drop them regardless. Generally, you hash that out in your contract. Anyways, the DE bit is used for frame relay traffic shaping as well, and we're going to go into this again in excruciating detail in future lessons, but we kind of touched on this a little bit with our admittedly probably shitty analogy about the two pipes sending water to the houses. And so when we saw that you were able to go above the value, your 64 gallons per second, again, it hammers home that concept of a guaranteed rate. So you were guaranteed that 64 gallons per second. Anytime you went over that, you could use it if it was available, but if it was being used, you're still locked into your 64 gallons per second. And just a real quick visualization of the frame relay traffic shaping. You can see here, CIR is your committed information rate. That's what you're guaranteed. You get to have that regardless of what's going on with the rest of the pipe, for lack of a better term. But you can see here, we're able to go above, and like this is when we're watering our lawn and the neighbor's not using any water. And we dip back up. And then generally you're going to have a burst value, and that's going to be the amount of additional bandwidth that you can burst up to. And your contract with your carrier is going to determine what that is. But you can see that once you hit that point, it starts dropping packets. It's going to say, okay, you can't go above this point. Now this point could be the full T1 in this case, but in a lot of cases it's going to be a portion of that. It's going to be a burst rate. Anyways, like I said, we'll get into this in a lot more detail. Just wanted to show you how the traffic flow looks when you're going up to your guaranteed bandwidth, and then beyond that, once you hit that plateau, they're going to just start dropping. Okay, and that's going to conclude our introduction to the frame relay protocol. Frame relay is a high-performance packet-switched WAN protocol that uses statistical multiplexing and variable length packets. It's going to operate at layer 2, or the data link layer of the OSI model, and we saw that you get a private line or leased line that's called a virtual circuit, and that comes in two different flavors. the bandwidth on demand switch virtual circuit, which you're unlikely to see, or the far more popular always on permanent virtual circuit, or PVC. There's a couple of different general device types for frame relay. DTE devices are going to be like your router that connects to the frame relay switch. The switch in this case will be the DCE device, and like I said, how I usually separate those is I concentrate on the C in DCE, and remember that stands for clocking, because that's going to be one of the most important things that that DCE device does. You use LMI, or local management interface, to communicate from the router to the frame relay switch, and that's going to give you a keep alive mechanism. You know, are you there, are you there, are you there, are you there? It's also going to give you information on which virtual circuits are available. So you're going to have the DELSI assignment is going to come from your carrier, and we'll take a look at that in a lot more detail in future lessons. So the DELSI is the layer 2 address that frame relay uses. It's a 10-bit data link connection identifier, DLCI, pronounced DELSI. They're locally significant. We saw that with that one slide, and they are kind of analogous to MAC addresses in Ethernet, with the two big stipulations that there's not really a true address resolution protocol with frame relay, and also again that they are locally significant. They are not globally unique addresses, although there are extensions to frame relay that will allow you to do that if you so choose and your carrier supports it. Frame relay has a lot of powerful features, including built-in congestion notification as well as traffic shaping, and we'll get to that in further lessons. So basically, frame relay, it's getting along in the tooth. It's been around since the late 80s, and technologies like MPLS and DSL are coming along, and they're quickly usurping its kingdom. It's coming out of favor a little bit, but there's still tons and tons of frame relay networks out there. It's a very popular WAN protocol, and it's something you're pretty likely to work with when you're out in the field, so it's in your best interest to learn as much as you can about this protocol. That's going to wrap this lesson up. I'm not going to do a lab portion for this because this is more theory based than lab, so once again I thank you for joining me in the Packet Lab, and as always I hope this helps you on your route to becoming a network god.